We continue on the working example, but before that, we quickly want to look at parallelogram as a plane shape. Parallelogram is a four-sided shape with two of each side parallel to each other, but none of its internal angle equals to 90 degrees. None of its internal angle equals 90 degrees, but two of its sides are parallel to each other. So this place is parallel to this, while this is parallel to this. So we compare it to square and rectangle. In case of square, one or four of the angle in the square are 90 degrees. That differentiates it from parallelogram. Likewise, in rectangle, four of its internal angle is 90 degrees, though the sides are also parallel to each other like the parallelogram. The only difference is that 90 degree is angle at the corner of those rectangle and square. Now let us look at perimeter of a parallelogram. Perimeter of a parallelogram. If you have a parallelogram in this manner, draw it very well. If you have a parallelogram in this manner, let's assume that we have a parallelogram in this manner, where this one is parallel to this and this is parallel to this. Assuming that this is A and this is B. So since they are parallel to each other, you can see that this one will be a transverse line. If we produce it, this one will also be a transverse line. If we produce it, that shows that this angle is equal to this angle, and also this angle will also be equivalent to this angle. So therefore, this length will be equal to this length. That means this place is also B. Then this length, because of the transverse line, this length will also be equal to this length. So if by virtue of perimeter of parallelogram will now be equal to A plus B plus A plus B. So you have 2A plus 2B. Then something is common. It will be 2 into A plus B, just like a rectangle. But the only difference is A and B are the parallel sides. A and B are the parallel sides. So let us now look at the proof of area of parallelogram. So if we want to get the area now, let's assume that we have a parallelogram again this way. If the parallelogram is like this, then we can have A, B, C, and D. So this one is parallel to this, is parallel to this is parallel to this. Now, if we want to prove, let us construct a line from A to C. So if we construct a line from A to C, we discover that it forms two triangles. That means area of parallelogram will be sum of area of the two that means it will be triangle, area of triangle ABC plus area of triangle ACD. Now, how do we now come about the area now? Let's assume that we draw a perpendicular to this, and that perpendicular happen to be H. Then let's assume that this is B, the base, and this is also B, the base. So since this length is equal to this length, so if we draw the height here also H, so that form the individual triangle. So area of triangle ABC will now be half of base, which is B, times what? Height. Then area of triangle ACD will also be half base times what? Height. So if we add the two together, it will be half base times height plus half base times what? Height. So from here, if we add it together, it will be 2 base times height over 2. Cross this one out, it will be base times height. That is the area of a parallelogram. Base times what? The height. So in the next episode, we are going to look at working example where we can apply this to solve some WAEC question, or probably Olympiad theory question. Ensure you share the video and also try to subscribe to our channel. Thank you.